problem of the day. I would like to start by saying a big thank you to all of you who have been supporting us. Those of you who have been sharing our WhatsApp group links, and then those of you who have been helping us in various means. Those of you who have been adding your friends, and those of you who have been inviting your friends, sharing our links and everything. We really appreciate every single thing that you are doing for us, and we promise you that we also come up with great things that will help you so that you pass your WASSCE and pass it well. So today's question is Emaths. Let alpha, beta be the roots of the quadratic equation s squared plus 2x minus 5 is equal to 0. And then the question is saying, without solving the quadratic equation, we are supposed to evaluate alpha squared plus beta squared, and then we are also supposed to evaluate alpha minus beta all square, and then we're also supposed to obtain a quadratic equation whose roots are alpha square plus 1 and then beta square plus 1. So this is a very simple question that you can solve, and I should start by saying, if you've not learned this topic, it doesn't mean you shouldn't watch this video. As a matter of fact, I will try my best to explain this to you very well so that you can get a fair knowledge about it, even if you have no idea about it. So we're going to start by showing our solution, and then the question has given us an equation which is s squared plus 2x minus 5 is equal to 0. And in this case, it gave us the first question that says we are supposed to evaluate alpha square and then beta square. And the reason why we have alpha square and beta square here is because we are supposed to let these things be the root. Okay, so over here we have the first one to be alpha square plus beta square. Alright, so let me just get to my black screen and then explain things to you. Actually, the formula that we use for this thing is that we are going to get s squared minus sum of roots x plus product of roots, something like this, is equal to 0. And in this case, our roots are giving us alpha and beta. So we have s squared minus alpha plus beta, which is the sum of roots x, plus the product of roots is alpha beta is equal to 0. So in this case, we are going to get s squared, where this is our sum and then this is our product. So the question gives us s squared plus 2x minus 5 is equal to 0. So now when we compare these, we know that x squared here is s squared here, and then this is this one here, and then the negative 5 is the product in here. So per comparing, we can say negative alpha plus beta is equal to 2, and then alpha beta is equal to negative 5. So in this case that we have this product and this in this case that we have the sum here and then the product here, we can say alpha plus beta is equal to negative 2, then alpha beta is equal to negative 5. And if I should prove further to you, which I will just give a summary of it, when we have something like the reason why we have these as root is because whenever you are solving this question, let me give you a real world problem. For instance, x plus 4 and then x plus 5 is equal to 0. When you expand this, you are going to get the quadratic equation where it will involve s squared plus blah 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 blah. And when we take this one, most of the times we take one of them, so x plus 4, and then we equate it to 0. So we are going to get x plus 4 is equal to 0, x is equal to negative 4, right? This negative 4 is one of the roots. So in here that we have alpha and beta, in other words, negative 4, and then the other one is going to be x plus 5 is equal to 0, x is equal to negative 5. This is another root. So when we talk of roots, results now after solving a quadratic equation and only a friendly root, no. And in this case, what they are my. And before I get back to my main work, I want you to get the concept here. That's why I'm up on my black screen. Over here, no. Now that we have this, no, we can go back to the question. So with the question in here, it gave us alpha square plus beta square, right? And let me give you a fair idea of it as well. Whenever we are given alpha square plus beta square, it is derived from alpha plus beta all square minus 2 alpha beta. And let me just reframe it. Send better say. So we have alpha plus beta all square, and most of the times it's equal to alpha square plus 2 alpha beta plus beta square. And then most of the times it's a plus b all to the power 2 now. Yes, expanded by a square plus 2ab plus b square. This time we are using alpha and then beta, okay? And when we continue with this same equation, we can say it's alpha plus beta all square is equal to alpha square. And then when I bring this one here, it will be plus beta square plus 2 alpha beta, okay? Here the same thing, I've just shift this one here and then bring this one here. So when we bring this one here, it's going to be alpha plus beta all square minus 2 alpha beta is equal to alpha square plus beta square. And then with that, we can now make this the subject. So in other words, alpha square plus beta square is equal to alpha plus beta all square minus 2 alpha beta. And so the question gave us this, but this is how we are going to solve it, okay? So let's get back to the question. So here in the question, we are supposed to get our sum of fruits and then product of fruit. But first of all, the formula is alpha plus beta all square minus 2 alpha beta, right? And with this equation that was given, we have s square plus 2x minus 5 is equal to 0. So in other words, s square, and then this one was the alpha plus beta x minus alpha beta is equal to 0, per the one that we were able to derive. So when we compare them, we are going to say this is equal to this, and then this is equal to this, and this is also equal to this. So negative alpha plus beta is equal to 2. Alpha plus beta is equal to negative 2. And then alpha beta, let me just do something like this, is equal to negative 5, okay? So now with the question, we can say that this alpha plus beta and a negative 2 are, and then this alpha beta is the negative 5 here. So with the question that we were able to say alpha square plus beta square is equal to alpha plus beta all square minus 2 alpha beta, we can say it is equal to, and then the sum, or the alpha plus beta was negative 2, so negative 2 all square minus 2 times the alpha beta was negative 5, so negative 5. So negative 2 all square will give you 4 minus 2 minus 2 minus 2 times minus 5 is going to give you positive 10, so plus 10. The result is 14. So over here, this alpha square plus beta square should give me 14, okay? So we are done with the first question. The second question says we're supposed to evaluate alpha minus beta all square. So when I get to my black screen, alpha minus beta all square is given as alpha square minus 2 alpha beta plus beta square. And most of the time, the time a plus b, this is supposed to be a minus b is equal to a square minus 2ab plus b square. So in this case, we can say alpha minus beta all square is equal to alpha square plus beta square minus 2 alpha beta, okay? So that is it. There is no square here. So our result is alpha square plus beta square minus 2 alpha beta. So let's get back to this. So we can say alpha minus beta all square is alpha square plus beta square minus 2 alpha beta. And in the question, we got to realize that alpha square plus beta square is 14 from the first question. So we can replace this by 14. So 14 minus 2, which is this 2. Then alpha beta is negative 10. Negative 5, I mean. So negative 5. So 14, negative 2 times negative 5 will give you 10 plus 10. That will give you 24. So the hard work is understanding how to get it. When you are done, the solution is simple. So the third question, we are supposed to obtain a quadratic equation whose roots are alpha square plus 1 and then beta square plus 1. So in this case, the formula that we had earlier is that s square minus sum x plus product is equal to 0. Let me get to my black screen. In this case, we were given alpha square plus 1 then beta square plus 1. Okay, so let me just first take the sum of roots. So sum will be alpha square plus 1 plus beta square plus 1. That's going to give me alpha square plus 1 plus beta square plus 1. So alpha square plus beta square plus 2. That is going to give me the sum of roots. And then the sum of roots. And then with the product of roots, that's going to give me alpha square plus 1 multiplying beta square plus 1. So with this, when we multiply, it's going to be alpha square beta square plus alpha square plus beta square plus 1. So I can say alpha beta all square plus alpha square plus beta square plus 1. So this is the product of roots. So in other words, s square minus, say you say have a sum of roots x plus, here will be product of roots is equal to 0. So it's going to be s square minus the sum of root in this case is alpha square plus beta square plus 2x plus the product of root is alpha beta all square plus alpha square plus beta square plus 1 is equal to 0. Actually, we can just derive this. So we know that the product of the sum of root is alpha square plus beta square plus 2. And we know that alpha square plus beta square, let me just get to my main screen so that we can continue from there. But remember, say we have the sum of root to be alpha square plus beta square plus 2, and then the product of root is alpha beta square plus alpha square plus beta square plus 1. So back to my screen. So we know that with this, the sum of root was, so sum, after solving it over there, we had it to be alpha square plus beta square plus 2. And then the product was equal to alpha beta all square plus alpha square plus beta square plus 1. So we know that alpha square plus beta square a 14 since we solved it here. So now when we put 14 here, we can say the sum is equal to 14 plus 2. That should give me 16. And then the product is equal to, you know that alpha beta a negative 5. So negative 5 all square plus alpha square plus beta square, don't see a 14. This one. So plus 14 plus 1. We have 25 plus 14 plus 1. That should give me 40. So now when we put that in the equation, we're going to get s square minus the sum of roots. We had that to be 16x plus the product of roots, that is 40, is equal to 0. So now we have s square minus 16x plus 40 is equal to 0. And this is our final result. So indeed, we've been able to solve the question very well. I hope, sir, you understood everything, and I've really enjoyed this particular question. Actually, we took quite a long time to solve this question because of the proving and the proving. I will make a full video on how this is done so that you get the concept very well. That even though if you've learned it in class and you didn't really get the understanding, you can still get a second chance to understand this. So kindly subscribe to the channel and then like the video, comment down as well concerning your views and then your thoughts. If you have any question, I will come and reply that quickly. And don't forget to join our WhatsApp group, link in the description as well. So thank you very much. I really appreciate your time.